Welcome to a new test and teardown video. Yes, this time it's another oscilloscope. And this one is from Trio. It's called CO-1303D. And this one is from about 1988 or something like that. I spent a little bit time on cleaning this one. It was not that dirty or bad or anything at all. I got this one at the latest flea market, and of course I got this one for sentimental reasons. I mean, it's super funny to find exactly this model. My father owned one when he was a young man, so I got a picture of this scope in his first recording studio. If you look at this picture in the top middle, you can actually see this this scope is standing there on the top. So that's actually quite funny. So now I got myself one, and I'm going to play a little bit with this one. It looks like it's in a good shape. It was super easy to find a manual with good quality, and those Japanese those manuals, and especially Trio manuals, they're like so nice and beautiful. Look at this drawing in the manual, how beautiful and nice that is made. I love it. And there's a block diagram that explains the internal parts of this oscilloscope, and that is so simple. There's almost nothing inside this oscilloscope. Let's just take a super fast look at the specifications. It's supposed to do up to 5 megahertz. So I think it's time to try and power it up and see if it works. So let's just have this one off, crank in the power, and hopefully we get light in that one. Let's turn this off, and then let's experiment with what have we got. Oop. What is that? Oh, this one is sticky. See, I got a little bit of internal synchronization. Why don't you get any? What am I doing wrong here? Oh, here we go. Oh, so it was all the way to the left. Ah, oh, that is stupid. Why would you have a pot meter here that can move it a kilometer out of the screen? That is stupid. Oh, I don't know if you can see this on the video, but that line is in a very sexy color. Yeah, I think it's... Oh, what is that? I can't see what it says here. So this is 1 kilohertz, and so here's the vertical gain, and look at that pot meter. Oh my god, I need to clean that. And if you look at the sweep, can you see this line here? This is the restart of the sweep, so this reveals there is no blanking. I mean, if you just know that this is just how it works, I think you can just accept it. See, here's the return sweep, and then this should definitely be able to do 5 megahertz. I can't wait to try and do that. Hey, I think let's just crank it up and see how that works. So that was 1 kilohertz, 100 kilohertz, tick, tick, tick. So this is the fastest we can go. And then we can also, oh yeah, okay. So if this is the fastest, so this is 100 kilohertz. I mean, that is something it can do easily fine. So let's crank up. So this is 1 megahertz. Oh, let's go down here and see. We can actually use the indications on the screen for this, because those are the dB, right? If I'm not mistaken, that is the idea. So this is oh, the reference is down there, right? So I think this is the idea. It's like that, right? So this is a reference. How does that work? I don't understand. So 0 and 3 and whatever. So if this is my reference, then 3 dB is 2 divisions down. And then I put it back to my reference down here. Maybe that is how it is. So that is what I should aim for, right? 2 divisions less than what you see now, right? And that was 200 kilohertz, and then we just crank it all the way up. So that was 3 megahertz, 4, 5, oh my goodness. 6, 7, 8. Okay, if this is 8. Really? 9? Can probably. Of course, you can't see anything. But yeah, well, there's definitely a lot of bandwidth. How is that possible? Yeah, so here you go. This is 11 megahertz. Okay, I need to fix this trace rotation, but I'm just reading over here. So, I mean, it's definitely doing. Let's go back to 5. What they kind of say, am I able to make this? See, I can't go any faster here, right? Yeah, but I can't make it trick on this. So that is no good. Oh, it's just so small. Okay. And 1 hertz. How about 50 hertz? How's that looking? Can we show that? So this is, yeah, here's your 50 hertz. Not bad at all. I want to go and have a look inside, and I definitely also want to fix this trace rotation. There's actually, with a scope like this, they didn't make a little screw to adjust for trace rotation. The trick here is on the back. All you have to do is loosen those 2 screws, and then just simply move the tube. This is directly mounted to your tube, and then yeah, that's kind of it. It's really lightweight and quite compact. Let's take a little look inside, and it is definitely nice and beautiful. There's a few cool details. Look about the transformer mounting. It's actually done in many different angles. See, I don't know if you can see this here in the video, but the transformer is not only tilted like this, but it's also tilted like that. And this is, of course, at this very, very specific angle, the magnetic coupling from the transformer to the CRT is the smallest. So they've been figuring out exactly, here we go, mounted that way. I love it. So let's look a little bit on the schematic. The schematic is very, very simple. There's only the parts needed, definitely, to solve this the quest. And I count 16 transistors in total. That is it. And in this area down here, that is the vertical deflection. It starts with this transistor here, and we've actually got 4 of them in here for low temperature drift and also for shielding, obviously. But now all this DC coupled stuff is super critical and all that kind of. So the output drive stage is here, and then the vertical deflection goes here up to a switch where you can switch from internal deflection or to external deflection using those screws here. And that is if you want to go a lot faster, you can of course deliver your own signals from your own amplifier and whatnot to go into the deflection. And when it comes to horizontal, it's all down here. Let's have a look at that. So that's all there is to it. I don't know if this angle is good. Let's try and rotate this. Yes, this is a little bit. Oh, here it's better. It's just impossible to get light in that hole. So here is the outputs transistors for the horizontal, and that is also the sweep. So the sweep generator is actually the first 2 transistors, and the last 3, that is the pre-drive and the push-pull drive for the horizontal deflection. And I found this. What do you think about that fuse holder? I think it has seen better days. It's just barely holding itself together. I don't know what the heck is going on here. And then there's a wire here that sticks out of the circuit board, and that wire is mains entry, and that goes through a, you can see it here. So this is the whole dingly ding. So there's of course supposed to be something in that hole, and that something is not here right now, so I'm going to fix that. And here's mains voltage selection that is done by soldering, and this is also explained in the manual. How do you like that soldering? Is that good and stable? It's probably good enough for today, I mean. But this is really nice. It's the voltages is also documented on the transformer, so that is quite nice and good. And now I wanted to clean, I think that was the potentiometer that I needed to fix. We got many more potentiometers, and I will fix them. I promised somebody that I will not say pot meter in it again, and I don't know if I can keep that promise. It's difficult to say everything right. But potentiometer, definitely 4 of those thingy. That is not a pot meter. There's another little nice detail I kind of like. Those service lids, once removed, you can access the circuit board from the bottom side without being able to, or being forced to poking the whole thing to pieces. All you wanted to do is just repair this and that, and I mean, you save 1,000,000 hours this way, right? See, I can access more or less the entire circuit board. All I want at the moment is to fix this fuse holder. And where the heck was that? Down there? Yes, I can actually access the fuse holder. But look, got some wires here a little bit too close to that. So yeah, that is something I want to fix. That is definitely way too bad. So I think that repair turned out to be quite alright. See, that is a new fuse holder. That is a lot better. I like this model a lot more. And also the mains wire. It's, see, now it's not hanging loose. Of course you need to be able to yank the wire a little bit, so that's how I did that. So yeah, I think it is more or less ready for my last little modification. Remember how stupid this position here is, that it can go a half a mile to each side. That is absolutely stupid. So I wanted to see if I can inspect the schematic and see if there is an easy fix so it's not moving so much. Looking at the schematic for H position, I see two resistors are 142 and 145. They're 12K each. So those are the end resistors for the potentiometer. So if I change those two to a higher value, that means H position will not be so aggressive. But there's actually an easier fix. It's just to put another resistor in parallel with VR3. So that is a 10K pot. So if I put in another 10K on the 2 points 1 and 3 on that potentiometer, that means I will exactly do the same. However, I will then heat up those two resistors. So if that is a problem, that is of course not a good idea. So now we'll go and measure a little bit on the voltages and see if what is the easiest fix for this problem. I was right about the circuit. It is a low voltage setup. I only had 7.8 volts over the pot meter, so I needed to add another 10K in parallel with the pot meter, and that was a super easy mod. And as you can see here, now I can move it plenty, but I can't make it disappear. So that is much more convenient. I actually think we should probably do the same with the vertical. See, it can also go out of the screen completely. And I mean, if it could only go to that point, I mean, that would be nice. So I think I'm gonna do the same with the vertical. So now I'm done with the modifications, and here is the result with the vertical. See, I went all the way down there, so it's just barely visible, and in the top it's actually also like that, and that is my maximum and minimum for horizontal. And the vertical pot meter is a 500 ohm pot meter, and it is mounted in the DC feedback, the emitters of the deflection here. So, and here it is. Those two wires here, they go to that pot meter. So I put in 680 ohms here because I didn't want to affect the tuning range way too much. Okay, so I'm almost done playing around with this thing. So thank you very much for watching. I hope you enjoyed the video. See you soon again. Bye bye.